Hi there, welcome back. Welcome back to a new restoration project, and this is the promised one from a couple of videos ago when I mentioned the 1 hour repair versus 2 week restoration. I'm not sure just how accurate the 2 week restoration period is, but we'll find out. This is the Telefunken Opus 8, and as I mentioned in the previous video, if you want to go and look at that, I'll link it above. I basically went through this and I wanted to get it to work in as short a time as possible to prove a point. I've had a lot of people agreeing with me. I've had quite a few people disagreeing with me, but that's fine. And the idea is that restoring one of these is not quite the same as repairing one of these. You can get these things working quite easily. In my opinion, this requires a lot more faffing around with and a lot more time and a lot more really getting into it and getting it restored to the point where you can be comfortable or confident that nothing's going to blow up on you. It can still blow up on you, but at least you reduce the odds. The point is, I love Telefunkens, and this is a magic radio. This one is one that preceded two really great Telefunkens that I've done before, the 2004 and the 2114. They're both Opus 2004 and Opus 2114, and I've got those on the channel. In fact, looking at my list of, I just quickly did a search to see how many radios, how many Telefunkens I've got on the channel at the moment. And the ones that I've recorded, and there are a few that I didn't do video series for. I did some of them before I actually started the channel. I have 6. This is number 7. I've got a Decapo 9, a Gavotte 55, a Jubilate, an Opus 2004, an Opus 2114, which is a stereo one, and the Operate 8, which was done quite a long time ago. That was actually given to a friend of mine and is using it every single day. And it's worked beautifully. So whatever I did there, I did right, thankfully. And I want to do the same for this guy. This is one of those epic radios because it came out at a time when the tube radio manufacturers, the ones from Germany I'm talking about, were sort of moving up in terms of, they're still keeping within the traditional quality level. They did a lot of really serious engineering on these radios, but there was a greater sort of demand for a richer sound, an even more spread out sound. And the result really was not so much changing the amplifier stages, but changing the speaker systems. When I show you the back of this, you'll see what I mean. This thing's got an amazing set of speakers. It is still mono, which is fine, but it has an amazing sound system. Now, I want to go quickly through the features of this because, as I said, if you've seen the previous video, this will be repetitive. And then I'm going to start with my usual procedure. And my usual procedure really is a formula, or rather a program that I follow when I do restorations of these. And it's really got, I think it follows a logical order. But before we carry on, I just want to thank the sponsors of this video. That's PCBWay, and you can visit them on PCBWay.com. Besides the amazing variety of boards and other services they provide, they've also got their 4th PCB design contest still going on. And that's another reason to visit them. Pretty amazing prizes on there. And they've started another one, and that is an actual opportunity to share your feedback. And again, they'll explain to you exactly how to do that, but the prizes are again quite amazing. So there are all sorts of reasons to visit the sponsors of the video. The links are in the description below. Enjoy. The first thing I do here is sort out the power supply. Now, obviously, without the power supply, what's the point of doing anything else, right? If you don't have power, you don't have audio. If you don't have audio and you don't have power, you don't have radio reception, right? So first, the power supply. And the power supply usually has a big impact on this because that is the part of the circuit that's under stress. High voltage, both coming in and leaving the power supply. That's where a lot of the stress is on components and so on. So that usually is a crucial section. The next stage is the audio section. So once the power supply is working, I then move on to the audio stage, which includes the preamp section and then the power amplifier stage. Again, because that is a crucial part of the radio. First the power supply, then if you don't have the audio stage working, you can have the best FM reception, you won't hear it, right? After that, I then go back in the schematic in the radio and I go to the actual radio stages. And that would mean AM and FM. This one's got both. It's got long wave, medium wave, and short wave. So the AM has 3 bands, but most of those 3 bands share one chain of circuitry. Mostly the oscillator section, the IF amplification and filtering stages. So when you get that done, you've basically got 3 bands working, okay? And you can align that and do all that jazz. And then finally, I go to the one that I like the best. It's the FM, because the FM to me is the one that's usable most today. I live on the island of Madeira, if you watch a channel, you probably know. We don't have much AM reception here. We have 1 AM station on broadcast band, on medium wave, and that's it. When I do the test of these radios, I get dozens of stations, but they are all from, well, not all, most of them are from the Canary Islands. And for some reason, the Spaniards in the Canary Islands still believe in medium wave broadcast band, which means that I can receive those bands here, especially at night, very, very well, actually. And then just about every night, I can pick up stuff from Morocco, from North Africa, because we're sort of across the water. It's quite far, but it's across the water. So I receive a lot of that on medium wave, and as I said, especially at night. Long wave is a strange one, because I know long wave in many countries has just gone down completely, okay? It's used for beacons and that sort of thing. In Madeira, here where I am, I actually pick up a few long wave stations. I pick up some from North Africa, and I actually pick up BBC4 from the south of England on 198 kilohertz, if I'm not mistaken. It doesn't come through clearly every night, but I can actually pick it up. So I'm able to test all these functions, and of course shortwave as well. I pick up a lot of stuff on shortwave. I can test all these functions and make sure that the AM section of the radio is working well. What's the point, you ask? Well, yeah. What is the point of restoring an AM section where somebody who owns this radio probably will never set it up? The point is, this is a restoration. I don't care that it doesn't get used. You know, just a side note, I watch a restoration channel, art restoration channel called Baumgartner, is it? Baumgartner, yeah. And he restores paintings, okay? And he restores stuff that the owners will never see. And the reason he gives for that is the same that I would give for restoring some of the things on this, that someone will never see. I know it's there. I know it's done, or I know it's not done. So because I'm doing this for myself, it's a hobby, I want to make sure that it's properly restored for my satisfaction. If it satisfies you as well, I'm happy about that. The FM is a different story. FM here is what we listen to mostly. And on these radios, these things pick up FM very, very well. In fact, I've tested this with a lot of people. The reception of FM on these radios, the sound that comes out is endlessly better than than modern equipment will produce. So I really focus on the FM. And then there's one more thing. On these radios, especially something like this, which has got an incredible sound system, this is an incredible tube audio amplifier, right? It's got a phono input, which you can use for other types of line level inputs, like a CD player or an MP3 player, or in my case, a Bluetooth receiver. You can put an external Bluetooth receiver into the phono input, and then you can stream any music you want, or any audio you want from your iPhone, from your phone, or from any device that's streaming Bluetooth, which means you've got a very high quality wireless audio amplifier, a tube audio amplifier and speakers. So what I normally do, and I will be doing it with this one, is to actually fit a Bluetooth receiver module inside the radio, completely removable if somebody wants to get this down to the purest level in the future. But this thing will have a Bluetooth receiver in there. The way I do this, I've had a project before where I've actually built a little board that receives commercial boards. And if you want, I'll just link that above and you can look at that. The way I actually fit it in sometimes changes depending what I find in there, how to get the supply and so on. But generally the rule is you click, you select pickup and it'll give you the Bluetooth reception. So that's the other thing I want to do on this one. But very, very quickly, let's have a look at the features on this and then we can get cracking on this. This thing is in excellent condition. It's got a few signs of age, especially on the woodwork, but nothing that's been really damaged, which is a real blessing. So this thing should be recoverable, restorable to a very, very high level. And if we look here first, we've got this is the volume control. This thing is the ferrite antenna rotator. It's got a rotator. You can see that those numbers moving there. It rotates the ferrite antenna, so you can put this on a desk or wherever you set this and rotate the ferrite antenna to the best reception. This was obviously important when the AM was the main feature. Then we've got the usual tone control. This is the bass control. Magic eye over there. Just a quick look at the glass. The dial glass is in perfect condition, nothing broken. While we're here, we'll just look at this. We've got the AM tuning on here. We've got the FM tuning down below. And I have checked the pointers are moving, so the dial chords are fine. This has got one other feature. When you set this to shortwave, then the FM tuning acts as a fine tuning. It really allows you to tune in to some of those stations that are just a little too crowded when you tune up on there, okay? And this thing has got a dial which reflects that. This dial down here, which is the FM over there, it's actually got KW loop or looper, which I believe means shortwave, magnifying glass, focus, whatever you want to call it. So you set this in the middle. Where are we? We'll set this in the middle. There it is there. And then when you tune into a station with the main tuning or around a station, you can fine tune it with the bottom one. Okay, here we've got the treble controls. All right. Then if we go across the piano keys, the usual. From the left, Aus, which is on off. Plata or plata, whatever it's called. That is the pickup input. Tonband is tape, so it's got two selectors on there. Then you've got lang, which is long wave. Then we've got something called Bandbreite, which is the band spread, bandwidth. So if you're on medium wave or if you're on short wave and you select this, you either widen or narrow. Yeah, there we go. So you choose short wave and you can either widen or narrow the bandwidth that you're going to receive. So you get better selectivity or better audio quality. I'll show you that when we get to the demonstration. We've got medium wave, short wave, and UKW, which is FM, the all-important FM. All the buttons seem to be working, which is great. Then here we've got something which is quite typical with these radios. It's a set of preset tone controls. So you push solo, and it gives you a certain selection of tone settings that are pre-programmed into this. Jazz will have a different type of setting, orchestra a different type of setting, and so on. And if you click them off, hang on, I think it's when you click them off that these guys come into effect. So you can do that by yourself as well. All right, so there's our logo. There's our Opus logo. Okay, and as you can see, the actual grill cloth looks like it was produced yesterday. This thing is in perfect condition. Let me take out the back and show you what it looks like. I always love this when you open up the back and you see an original schematic in there. Not that it'd be difficult to find, but it's great to have one of these originals. This thing is, about 60 something years old. Brilliant. Now we have the usual story, transformer. This is the power amplifier section here. This is a push-pull section, so it's got two EL84 tubes. I told you it was a great PA. The preamp section, there's a little tube in the middle there. I'm not sure what that does. It might be the phase inverter for the push-pull. We'll see. Audio transformer at the back there. Quite a hefty one. It has to be because look at this. Not one, but two massive speakers. This is bloody brilliant. These things are amazing. And then it's also got a mid-range and the high-frequency electrostatic tweeters. So this thing's got it all. And on the other side, it's got another set of those. So this thing is no mystery. It's the usual story. You've got IF amplifiers there. I think that's probably a EF89 IF amplifier. That one's another one. The two IF transformers. That there would be the ECH81 mixer oscillator. The filter capacitor. The FM block at the front there with its own ECC85. And if you saw the previous video, you'll see this thing was completely knocked off and disconnected. I did that for the repair. The tuning condenser over there. So yeah, nothing Nothing surprising except for how much of it there is. Look at that. I love it. Well, I'm not going to go into too much blab about this. I'm going to take this out of the chassis. I'm going to be careful about how I do this because I want to disconnect the speakers. Make sure I need to desolder these guys over here, and that takes care of those speakers. And then I've got to desolder these two over here, and then stay with me, and then these two over there. Got to make sure I insulate those because this is high voltage. These are electrostatic tweeters that work on high voltage on the B+ supply. So I need to insulate these things so we don't touch them. And I think this thing will come out quite easily. We'll see. Well, she's out of the cabinet. I've put it on my stands as usual. Makes it easy to work with. And let's have a look inside. First thing I noticed here, this thing's got a transformer here, and I don't see the output transformers at the top, as I mentioned before. And I've been looking at the oh, I've just remembered what this is. Okay, this is a choke. This is not a transformer. This is a choke on the power supply line. That's pretty rare. You don't normally see chokes. I think this is the first time I've seen a choke on a power supply line in one of these radios. These guys didn't spare expense. The flywheel, just to make the tuning smoother, the turning smoother. And then we see the usual complement of resistors and capacitors and all sorts of stuff. And I've noticed something. These capacitors most of these are ceramics. So those normally hold out quite well. I know there are paper ones there as well somewhere. A few electrolytics on there, those tubular ones. There's a paper one there. Those are the ones that usually cause quite a few problems. They leak. There's some more down there. That black one, I'm not sure what that is. I think this is one of the ones that leaks as well. Anyway, they'll all be tested and changed if necessary. Oh, yeah. Those black ones I seem to recall are pretty bad. Here's another one of the black ones in a paper cap. But there aren't that many. There's quite a few coils on here, obviously, for the AM bands. But as far as capacitors are concerned, there aren't that many. There's the one that I swapped down there. There's another one or two underneath, which are pretty difficult to get to. Some more on the audio shaping circuits back there. Yeah, quite the usual. But everything looks to be in order in here. Those are the tone control pots, which are open. So they normally get quite a lot of dust. Here's the other one. They get really dusty, you've got to clean them up. But they normally hold out quite well. These guys all look okay. And you can actually get to them quite easily to clean, which is a blessing. And the actual switching mechanism down here as well. You've got to spray some contact cleaner in those. And you have to pay special attention to all these little wires, these little hair wires on the coils. If you brush to clean too vigorously, you just swipe one of those and you create endless trouble trying to find the problem. So yeah, this is exactly what I expected. It's actually a lot more compact, or rather a lot smaller. Not compact, a lot smaller than I expected. I expected a lot more circuitry. If you remember the Cyber Breisgau when I opened up the bottom, I'll link that above. It's sort of the same level, same age as this one. And when you open that back up, the insides are completely different. So yeah, I think that's why they justify the price difference in those radios. There really was a big price difference. I removed the faceplate because I certainly don't want to break that, and we can get a good look at all these. There's the magic eye. There's the dial that you can use as a reference for your antenna, your ferrite antenna. And the way this works is, if you look at the antenna, when I rotate this, it rotates. Okay, and obviously the string is fine. The chords are fine. Quite a lot of, there's those chords, they're fine. All these chords seem to be fine because everything is turning. Okay, there's, what is that? Is that the flywheel? Why is that flywheel at the back and the front? I'm not sure. Have a look at these. Everything's a little dirty, but nothing too dramatic. These things over here sort of close a gap. As you change it, it closes a gap, a window on the front panel through the glass. Okay. 2 dial lamps. Pretty easily accessible if they're burnt. I think one of them's burnt out. I'm not sure. Try and recall for when I did the test drive. And as for the top, nothing unexpected. There are the 2 output tubes with the one in the middle, which I think is a phase inverter. That's the ABC80 inside the can, which is the detector. And then some IF amplifiers. And then right at the front, we've got the mix oscillator. And here we've got the ECC85, which is the FM. This FM block is completely independent, really. So all these very, very sensitive FM circuitry is inside the block. And when you get one of these, you pray that it's not necessary to open it up. And I'm not sure that it is, because as we've done a test, a rather rugged test, it seems to be working. So I think we're going to be saved that hassle. This ferrite antenna obviously came loose, so I need to find a different type of fixing for that, which should be quite easy. The dust isn't too bad. I don't see any rust, which is a blessing as well. That's pretty good. There's the output transformer, which serves more or less as a hookup point for a lot of contacts. A lot of components on there. Some capacitors. Those will all need to be changed. There's an electrolytic down here, which is odd. Don't know what that was for, but we'll see on the schematic. So yeah, that's what we've got so far. So where's a good place to start? Well, the beginning. And the beginning is the mains in, the mains connection. And what I had here was this plug. It seems to be some sort of oldish plug, but I've never seen one like this before. It does have ground on there, or the earth, but because this is a 2-wire connector, obviously the earth is not connected. So we know that this is just mains, live and neutral, and I wanted to put a 3-wire connection so that I can actually earth the chassis, which is a good idea. And I did that. I got this is actually very good quality wire. I can't remember where I bought it. I've got to get some more because it's sort of silicone. It's sort of nice and flexible. It's soft and flexible. I've got to get some more. But anyway, 3-prong plug. It's got live, neutral, and our earth. Okay. Now here, these things are not polarized. This can go in either way, so we can't really go for the live and neutral selection. But then what I did is I brought it in, brought it up to here. The neutral goes to the fuse. It's exactly as it is in the schematic. And then the live goes to the switch, and then from the switch it goes off to the transformer. But I want to show you something. One of the ways to test if this is working is if you put a multimeter across the 2 prongs, right? Think about what you've got in the schematic. You've got you've got the fuse, you've got the switch, and then you've got the primary of the transformer. So you should be measuring the primary. And that's exactly what we're getting over there. If I switch this, the radio off, it's open circuit. If I switch it on, I should get fairly low resistance, and I don't. And why is that? I mean, we know this thing works, right? We know it works. So why is this thing misbehaving? And it was actually on just now. Let's try again. Now we've got 6 meg or something. This thing is going all over the place. Let me show you why. If I take this one off here, let's try with a neutral. And I measure, the neutral is the blue wire over there. And if I measure to where it's coming in here, I get 0 ohms. Well, near as damn it, right? If I measure on this side of the fuse, Oh, now it's giving me 7. It was giving me a few meg earlier on. Just when you want to show something, it doesn't work. Okay, there we go. See that? 2K, 4K, well, meg. And the fuse is in. And all it is, it's dirty contacts. Now it's got 30, this thing is all over the place, right? And this is just a fuse. And the fuse is not burnt out. I know that because if I do this, and I put it just across the fuse connections, 1 ohm. That's just basically the leads and everything else. So what we find here is because of dirty contacts here, like on the fuse connector, on the switch itself, you will find high resistance. And what happens when you put power to this? Well, what we're measuring here is with the voltage that the multimeter provides. I don't even know exactly what it is, but you know, it's a low voltage. So it doesn't have enough potential to break through or break across any kind of dirt that you have on here. When you put power to this, you've got 230, 240 volts. It'll get through. And believe me, it'll get through. It's like the difference between you touching this and touching the wire. It'll get through, and what seems to be an open circuit will suddenly start working. See? Now, if I clean these contacts, that'll go down to 0. Let me just do that quickly. Let's try again. There we go. There's a small resistance on there, but now it seems to be okay. And now if I measure on this side, I've still got that. And my switch is on. So what I need to do is I need to clean the switch. Let's just leave this on there. If I hit the switch a few times, on and off, see it changes completely. So I'm going to spray some contact cleaner into the switch, and fortunately this is one of those old switches that you can actually get to. And to activate it, you've just got to still not there. We should get a fixed amount because that's a resistance of the resistance of the primary is something that's fixed. That's where it should be, 34, 35 ohms. And it's now sort of coming back to that. There we go. It seems that we've cleaned the contacts. Now what we've done is we've just cleaned the contacts enough for the low voltage signal, test signal for ohms on the multimeter to go straight through. And that is the primary we're measuring. So our primary circuit is now tested, complete. And we do have to check something else. Let me show you. This thing's got a voltage selector at the back. And as we can see, as it is there, it's 33 ohms. Let's see what we've got there. This thing is set to 220 volts. And it's giving us that 30-something ohms. Now if I change that, coin normally works best. $39 ohms. So it's more windings. In other words, it's expecting a higher voltage, which is what we've got, 240 instead of 220. And I'm going to leave it on 240 because that's about what we've got here. We've got 230 something. So that's it. Our primary circuit is tested. And I now need to carry on and work on the secondary circuit and see what we need to do. And here's the first correction I need to make. I mentioned in the introduction this was a filter cap. Yeah, obviously it's not. It's the selenium rectifier. It's one of those tubular ones, but basically all it's got inside is 4 diodes, right? And yet the green ones are coming from the transformer. So you've got AC in, those two. And then you've got ground, which is really sort of hardwired to the chassis over here. And we've got our B plus coming out here. And I probably will be changing this at the end, but what I'm going to do is leave it as it is for now. Wait till I know exactly what voltages I'm getting after I've done the full restoration. That means that all the capacitors are sorted out and there's no leakage going on and everything is drawing what it should be drawing. And then I'll see what B plus I get. It'll probably be a bit low because these things, when they get old, two things happen. They start increasing the voltage drop, so your B plus becomes lower, and they also sometimes just go poof, and then they stink like high heaven. So I will be replacing it, but to know how much current this thing will be drawing, to know what sort of B plus I will be getting, I'll wait till the end. So that's the selenium rectifier, which makes this guy our first target. This is the tuning, the filter capacitor 2x50 microfarads. And it says here 350 volts AC, 385 volts DC, 70 degrees C. This guy I want to change because this is the first thing that will make quite a difference if we have hum. And to get to that, we'll get to the underside and decide what kind of intervention it deserves. And here it is. Quite easily accessible. It's got two caps. There's the ground connected to the chassis. There's the one, there's the other. So nothing unusual here. And I could remove it and stuff it, but I want to try something else. Let's see how far we get with this. So what the heck is that? Well, I decided to use one of the boards that I made recently, which is a little board that lets you fit two capacitors on, and then you connect the ground to a ground pin at the back here and bypass the caps on the top. What I did is I removed the two wires. It's those two wires there, and this one's actually quite easy because it's only two, one each. Remove that, and I bent the capacitor tags down. In other words, basically shorted them to ground. So the original capacitors inside the can are completely out of circuit, all right? These two caps then fit on the board, and the ground comes to that ground tag at the back here. I raised it a bit and fitted that through the hole in this little board, this circular board, and soldered it there. And of course, on it, I've got two 47 microfarad capacitors at 400 volts, I think these are. I'm actually waiting for some, I think it's Nishikons that are 450 volts, and they are the thin type. So when they arrive, I'll probably replace these. These are just temporary, just to show how this works and to test it and carry on with the restoration. And then, of course, I've got the two connections for the two caps where the wires have been soldered to. And this is actually the first time I've used one of these. You have to have space on the underside to make sure that fits, and in this case it does. And yeah, that was quick. That was really quick. And it was a hell of a lot quicker than restuffing the cap. And as far as the top side's concerned, it looks exactly the same because I've changed nothing. So yeah, I'll put a link above to the little project where I did these boards, and you'll see what I mean. I explained it in a little bit more detail on there. There's also actually a selenium rectifier replacement board that comes together with these boards. Okay, so I have done the filter capacitors, and I want to show you on the schematic what has been done so far. Here's our full schematic, and the part we're interested in is basically right at the beginning here. What have we done? Well, we've done this. We've checked the fuse. We've made the selection to 240 volts. We know that that is fine, and we know that the switch is working. So that section we can paint in green. I'm not even interested in checking these because I'm never going to use them, but I know they're fine. Then what we've done is we've gone to here, and we know that it's coming. I know that it's coming to there. I've actually checked the continuity on there, and I have not done the selenium rectifier. I know that it's connected to ground. I have not done the selenium rectifier, but then if we carry on here, we follow this line from there, and it goes to the first filter cap. And that one, which is connected to ground, I have replaced. Okay, Now we know that this capacitor then goes on and it goes to a choke. And then there's that filter capacitor. Now I've checked this and that's all fine. So from here, we normally get a resistor. In this case, we've got a choke, which is fine. And we've replaced that one as well. And so we've started to paint our little schematic. Not much done, but yeah, that's where it is so far. And that's the idea. These two have now been replaced. This one I'm leaving for now. And what I'm going to do next is continue with the power supply. I've got to check that the supply gets to where it's supposed to. There's another 2 microfarad electrolytic over here, which I need to replace. And the rest are, I'm just following the line here. The rest are the usual supply. And it goes up here. This one goes up here. What we normally get is we get this supply going up to there, coming out here, and then from here, it normally goes to the next cap. They've gone one step further and given it a cleaner supply. Oh no, of course they can't do that because this is push-pull. Idiot, Manuel. Yeah, with push-pull you can't use part of the transformer as a sort of a hum rejector. Okay, makes sense. That's why they've got the choke. So what I'm going to do next is I'm going to check all the supply lines from these two B pluses. I call that B1 plus and that one B2 plus. I'm going to check where they go, make sure they go to where they're supposed to, measure the resistors along the way, make sure that they're fine, measure the coils along the way, make sure that they've got continuity, and make sure that the entire supply line, the entire B plus supply line is satisfactory before I start on the audio section. But what I'm going to do, this is very, very tedious to do this one little step at a time. I'm going to do all that and come back to you very, very soon with a report on what I find. So for now, I'm going to thank you for watching. If you enjoyed that, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Links are in the description below. Once again, thanks for watching. Bye for now and stay safe.